So today what we're looking at are the perimeter and area of parallelograms and triangles. We've actually already done squares and rectangles in chapter 1, but some of those will show up again from that section. So we have two new formulas. Well, this one is not new. Area of a rectangle, base times height. Some of you also use length times width. Doesn't matter. The area of a parallelogram is actually the same thing because a rectangle is a parallelogram. However, you just have to notice that the base will be one of the sides. It could be the bottom or it could be the left. But the base and height have to be related by a perpendicular box. Okay, so whichever base and height you choose have to be perpendicular. So the area of a parallelogram is also base times height. Now, if you look down here, either side of the parallelogram can serve as the base. So you could use this base and this height, which would be, the area would be then 14 times h1. Or you could use the 8, because they've kind of flipped that picture. You cannot use the 14, that's the height. The height would actually fall outside of the shape. Make sure you do not include this imaginary part that is not part of the parallelogram. That's just an extension to help you find the altitude or the height. So you would multiply 8 times h2. Maybe make a note. Do not include that little piece. And a base and a height have to be perpendicular. But if it falls outside of the shape, you're only using the base that actually exists. And our triangle formula, which most of you learned in middle school, which is 1/2 times the base times the height. Again, base and height have to be perpendicular. Base does not mean bottom. It could be the top side as long as it has a height that is perpendicular. All we're going to do today is apply the formulas. Number 1, find the area of the triangle. So first of all, start out with the appropriate formula. You'll see me put little symbols like this because you're going to learn, I think, 8 or 9 area formulas. So just to know which area formula you're using, I usually put the shape next to A. Now, what base and height will I choose out of all the numbers in my picture? There's only one correct answer. Jeremiah? Yes. Remember, base and height have to be perpendicular. So you're looking for your right angle box. That's going to indicate that this is your base and this is your height. These numbers are there to trick you. You don't need them. Okay? That will happen a lot. And then all we have to do is multiply those together. What we get for our final answer with correct units. With correct units. 75, but centimeters squared. So remember, area is really, you're taking the area, you're seeing how many little squares fit inside of there. So just remember to use square units. And the area of the parallelogram, so we use the area of a parallelogram, which is base times height. The only way you can screw this up is picking the wrong numbers to plug in. Okay. So what do I plug in as my base and height? 7 times 11, base, height. 9 is there to trick you. And this would also be centimeters squared. Number 3, they give us the area of a triangle. They want us to find the missing length of the triangle. So we'll use the area of a triangle formula. They give us the area, which is meters squared. That does not mean you square 20. 20 is just 20. So 20 will go in for the area. The base is 5. That goes in for B. H, we don't know. So then we just have to solve out for H. So I would multiply 1/2 times 5. And then I would use inverse operations. So what do we get for the answer of H, and what correct units would we use? Make sure you do not put meter squared. Meter squared is only 3. Alright, see if you can do the bottom ones, or if you haven't already, find the area of each triangle. Alright, the ones on the back get just a little bit more tricky because we will be asked to find a height or a base, and we don't know the area. So back on the front, I gave you the area and you could solve out for a base. On the back, I just ask you to find the missing height, but you don't know what the area is. So step 1 is going to be to find out what the area is, and then step 2 will be to use that area to work backwards and find out what the missing height or base is. So step 1, we'll find the area of the parallelogram using a base and height that we do know. So who can identify a base and a height that we do know that would correspond to one another? Marquise?
Base 10 and 26.
Good. Base is 10. Height is 6. Now, remember, the area of this shape stays the same whether you use this base and this height or this base and this height. Base times height has to still get you the same number of square units inside. So we will use the area formula again, knowing that the area has to remain 60 square centimeters no matter which base and height we use. We'll plug in 60 for the area. We'll use the other base. So if this is 5 centimeters, this is 5 centimeters because the parallelogram has opposite sides that are congruent. So this base, and maybe draw it differently, corresponds to this height. So 5 times h has to still equal 60. So we divide both sides by 5. And we'll get that the height is 12 centimeters. Now, a lot of you on your homework will try to figure out what that is using right triangles. You will not have enough information to do Pythagorean theorem or subtotal or anything. So this is going to be the only way you can do it, is by finding out what the area is and then using the area to work backwards and find the missing length. Okay, a triangle question. Similar. Find the height. Now you could use geometric mean for this if you really wanted to. Okay, you could label this like x and y and do geometric mean. But I'm going to show you the alternative, which is the same process as what we just did. So we'll first find the area, and then we'll use the area. Area of a triangle, 1/2 base height. What is a pair of base and height measurements that we do know in the picture? Maddie? 6 and 8. It doesn't matter where. Which means the amount of square inches that fit inside of here are 24. So now we're going to use the area formula, plugging the 24 in for A because it has to stay the same. And then this time we'll use the 10 as the base, and its corresponding height would be h. solve out for h. Half of 10 is 5. Divide by 5 on both sides. And we'll get that h is 4.8 inches. Okay, the last two are irregular shapes. So they are not just one specific shape. They want us to find the area of this shape. So, and sometimes they'll even shade it. So normally I would say let's find the area of each triangle and add them together, right? Find the area of this, add it to this, be done. But the problem is we don't know the base. We know it's all 24, but we don't know what each little part is. Does anyone see another way we could find the area of this shape besides adding them together? Jess? Yes. Make a rectangle and a third triangle. Very good. So you can actually find the area of the rectangle, this big thing, and then subtract out the triangle. So the area of a rectangle is just multiplying the length times the width, or the base times the height, which the base and height are 24 and 10. Which will give me 240. Now the formula for a triangle, 1/2 base height. At the time, you might think we don't know what the base and the height are, but if you know this is 24, you'll know this is 24. And if you know a perpendicular distance from the top to the bottom is 10, you could draw in a perpendicular distance that is also still 10. That would be my base. This would be my height. Which would get me 120. And then at the end, we'll subtract those and get 120. Now some students will say, Mrs. Bennett, is it always going to be half? No, not necessarily. That just happens to occur on this question. But it will not always be half. Okay, the last one, we have another irregular shape. How do you think I should attack this problem? To find the area of the whole shape. And there's multiple ways to do it. Try. He said make 2 rectangles and a triangle. So here, here, and here. That works. Anyone see a different way to do it? Justin? Then you just have 1 rectangle and 1 triangle. That works too. Now, eventually you could actually extend this and then subtract, but you'll end up getting a trapezoid. You don't know the area of a trapezoid yet. We'll learn that coming up. But you could break it into a rectangle, a triangle, and subtract. But the easiest way would probably be just finding the area of this rectangle and adding the area of this triangle. Now let's figure out what the dimensions are. The rectangle is easy. It's a 9 by 11. What would the dimensions of the triangle be? Maddie? Good. 5 and 4, because 11 minus 6 is 5, and 13 minus 9 is 4. Make sure you realize that's all. So this would be 5 and 4. You do not need to find the hypotenuse, because you're just finding the area. So the area of a rectangle is length times width. The area of a triangle is 1/2 times base times height. we'll get 99 plus 10 will get us 109 square meters. See if you guys can try the closure while I'm messing up the homework. So how can I find the height corresponding to the 18-inch base? And find out what that height is. Plug 135 in for A. So find the area, use the area. So the area goes in for A. The base that we're using this time is 18. The height is what we're looking for. Divide both sides by 18, and we should get 17.5. Excuse me, 7.5. The rest of the time is yours to work on the homework.